So like previously when when the brass age and the bronze age, like basically they were people were much focused with single material, okay? Or up to a maximum extent, if they are going, they will just focus with some kind of alloys, metal alloys focused, okay? So the metal alloys, the major disadvantage what they have faced is like the some properties are good for some kind of materials, whereas some other materials lack some properties. So these were the issues which were faced. So let us see some of them. Okay, so here in the aerospace application itself, okay, they need some kind of material which we need like low densities, which is strong, stiff, and impact resistant. Okay, like if we use some metal alloy itself, sometimes we will not achieve that. Okay, on some other cases, like if we take some ceramics alone, you know that it is hard. So like it has got good fracture toughness, but those one doesn't have some ductile properties. But if we go and see some polymeric materials, it has ductility. Ductile properties are basically at the room temperature, but it doesn't have the hardness. Okay. Similarly, for metal alloys also some disadvantage and advantage. So in the modern technology, what they have used is that they have used the combinations of these properties. Okay, combinations of these material like metal alloys, ceramics, polymeric materials, etc. Okay, so this the combination, what is benefit is that they have if we combine the materials, we will get some strong materials which is relatively dense. Density will be good, so increase the strength, impact. So here the composite basically uses the principle of combined action. So what do you mean by combined action? That's better property combinations are fashioned by judicious combinations of two or more distinct materials like metal alloy or ceramics or polymer materials, whatever it is. Composite is a material which is made from two or more different materials that when combined are stronger than those individual material by themselves. Okay, if we combine metal with some kind of polymeric materials, so the combination will give some more high strength material and improved properties. This is basically focused for engineering applications. Okay, so here these are the phases which is present in the composites. There are basically two phases. First one is a continuous phase. Okay, continuous phase is also known as matrix. So the major part of that thing will be the matrix. And if we see, there will be second phase that is known as dispersed phase. Okay, the fiber reinforced with concrete. So if you see, you can see that the rods which is passed through the concrete. So it's basically a composite. The rods will carry strength and the bulk will be filled by the continuous phase. So it has two phases. First one is known as the continuous phase, which is known as matrix, and second one is known as the dispersed phase, that is this fibers, and it's also known as fiber. Composites are classified basically into three types. That is, first one is known as the particle reinforced, second is the fiber reinforced, and third one is the structural type. Okay. Particle reinforced are widely classified into, the first one is known as large particle, second one is the dispersion strength. Again, the fiber one, which we have just seen before, for the introduce the phases which are present in composite. consists of two types. The first one is continuous and the second one is discontinuous. So the continuous, here we can say that it is an aligned one. As we have seen here, this is the continuous one. Okay, it's aligned, well aligned. So discontinuous is the short, and it also divided into two, that is it's aligned or randomly oriented. Third one is a structural type. Here it's laminates and sandwich one. We will see this one in detail. The first one is the particle reinforced composites. So the particle reinforced composites are classified widely into two. The first one is large particle reinforced composite, and second one is the dispersion strengthened composite.